the James Webb Space Telescope has detected light beyond the Dark Ages, a period of time that began just after the Big Bang and lasted about 1 billion years. During this time, the universe was supposedly filled with dense clouds of neutral hydrogen gas that blocked out all light, making direct observations of early galaxies long considered nearly impossible. But now, scientists have found that strange sources of light are coming from these dark ages, and we must seriously wonder if we have misunderstood the universe so far. Using the James Webb Space Telescope, or JWST for short, the mystery of the Dark Ages has now been solved. The telescope's discoveries show that there was indeed light during the supposed Dark Ages. Webb observed Lyman alpha emissions, which are produced by the interaction of ultraviolet light from young hot stars with surrounding hydrogen gas. Surprisingly, this light reaches us, so it was somehow able to penetrate the dense hydrogen clouds of the Dark Ages. Researchers speculate that this was most likely made possible by the formation of bubbles and channels of ionized hydrogen. The ionized hydrogen came from the first stars and galaxies, which created bubbles and channels, and thus gaps, in the neutral hydrogen gas. It was through these gaps that the Lyman alpha emissions escaped. The first discovery of Lyman alpha emissions from this epoch was some time ago, even before the launch of the new space telescope. Researchers were able to receive and study these faint signals from a largely unexplored period. The Webb telescope is now showing us yet another facet of this discovery, and it has far better capabilities to detect and analyze the Lyman alpha rays. So far, the overall picture suggests that the first galaxies and stars were formed much earlier and on a larger scale than previously thought. Since its launch in 2022, the JWST has shown us a series of galaxies that were already very advanced and bright during the Dark Ages. The very fact that we can see these galaxies shows that there was even more light in the Dark Ages than previously thought, and that the Lyman alpha emissions were not the only waves that penetrated the darkness of space. So far, the discovered galaxies show all signs of an extreme star formation rate, and they are unusually large. The evidence of intense star formation alone paints a very different picture of the early age of the universe. If there were more stars in the past, then the universe was also illuminated and permeable to light earlier. Based on the current situation, scientists must also come to terms with the idea that the Dark Ages never existed. One of the most significant discoveries of the JWST are two high redshift galaxies that are so old that they existed long before the Dark Ages. The age of these galaxies is so extreme that, strictly speaking, they must have existed even before the Big Bang. This shows that something is wrong with our previous data. These galaxies have an extremely large number of properties that do not match the previous models of the origin of the universe. Another example that is currently giving scientists a headache is the discovery of a supermassive black hole at the center of one of these galaxies, which existed only 400 million years after the Big Bang. Such observations completely challenge the current understanding of the cosmological time scale and our old theories of galaxy formation. The real reason behind Lyman alpha radiation is still being studied. What is certain is that Lyman alpha galaxies play a crucial role in the study of early galaxy formation and evolution. Now we just need to find out what exactly these emissions are telling us. Lyman alpha emissions are produced by the transition of electrons in the hydrogen atom and are normally found in the ultraviolet spectrum. From our point of view, however, the emissions are increasingly redshifted because the universe is expanding, and the light of the waves changes optically for us. As a result, however, this effect gives us the good fortune of being able to better capture and study the emissions. The JWST is virtually predestined to capture waves in the red light spectrum. Lyman alpha emissions, or LAE for short, are like a silent beacon for scientists from the times that we have long considered to be the earliest phases of the universe. They enable astronomers to identify and study processes in galaxies that took place just a few 100 million years after the Big Bang. This should actually be the time period in which the first structures in the universe were formed, and LAEs would therefore be important messengers of this time. However, emissions can also play an important role in changing our view of the universe. This is because we no longer know whether the idea of the Big Bang is really true. All observations are important new indications of a worldview that is different. Scientists wanted to use LAEs to clarify the processes of the reionization epoch. Until now, the idea was as follows: after the Big Bang, the universe went through the so-called Dark Ages, a period in which there was no light because there were no stars or galaxies that could produce it. On top of that, the universe was still a very dense soup where light rays could not have passed through. The point at which the universe became bright and permeable to light is what scientists call reionization. LAEs must have played a key role in this. But what if neither a dark age nor reionization really existed? Then researchers have misinterpreted the LAE so far. Thanks to the latest discoveries from the Webb telescope, the picture is becoming clearer now. By studying LAEs, scientists can better understand what was going on in the galaxies Webb shows us. LAEs provide reliable information about how many new young stars have formed in galaxies and how the intergalactic medium has behaved during this epoch. By studying LAEs intensively with the latest telescopes, scientists will continue to gain more information about star formation rates in early galaxies, and this data will help us piece together the puzzle. Eventually, we will know if these galaxies are really baby galaxies in a young universe or if these galaxies formed in a completely different way and are much older. The images that the JWST has provided us with so far show astonishingly starry and bright galaxies. If we want to understand what happened in these galaxies, we need to use every available source of information. Another high-power telescope, the Vera Rubin Observatory, will soon be launched to give us even more clarity. All we know at the moment is that the strength of the Lyman alpha emission is often an important indicator of the amount of new star formation. The jets are also produced in star-forming regions that are much younger. By measuring and analyzing these emissions, scientists can quantify star formation activity in early galaxies and thus draw conclusions about the processes that led to the formation and evolution of these galaxies. Webb discovers more and more LAE galaxies. What this telescope is accomplishing is truly mind-boggling. The James Webb Space Telescope is looking farther and farther back than any other telescope before it, and it has revealed impressive examples of Lyman alpha emitters that are now so important to research. One of the most notable of these discoveries is the galaxy GN-Z11, originally identified by the Hubble Space Telescope and later confirmed by the JWST.